Hey everyone, in this video I will show you how to accurately align multiple LiDAR scans using a checkerboard marker. I'll be demonstrating with the SHARE S20 LiDAR scanner, and for proper alignment you will need at least 4 checkerboard markers. The board that you see here was 3D printed, and I will include a download link in the description. For the first scan, I will have RTK turn on and walk in a small loop around the checkerboard. This will serve as the fixed reference scan that the next one will align to. For the second scan, I will switch to SLAM mode. I will walk a loop and use the ground control point function to capture the 4 points at the center of the marker boards. Once the GCPs are aligned, this scan will lock onto the first RTK reference scan. This method is perfect for indoor or semi-indoor area where you still need georeferencing. I'm starting the first scan with RTK Enable. With the latest firmware update, the app now prompts you to walk in an S-shaped pattern for the first 30 meters. Some scanner asks for figure 8, other for an S. Both are normal. The idea is to give the system more leverage and improve ground level accuracy. This scan will serve as the fixed reference, so we won't be collecting any GCPs here. Just make sure every checkerboard marker is captured clearly. If you are not confident about capturing at least 4 boards, you can always add more to be safe. Now I'm starting the second scan, walking in a loop. RTK is still turned on, but I won't be using it during the remapping process. Before we start collecting ground control points, let me quickly explain how this function works. In a SLAM LiDAR scanner, GCPs are only used for aligned scan data. They can't collect translation or rotational drift errors. So while GCPs help with alignment, they won't improve the overall accuracy of the scan itself. There are 6 degrees of freedom when it's come to drift error, 3 in translation and 3 in rotation. These errors aren't constant throughout the scan, and they can't be corrected just by scaling. The only way to improve SLAM LiDAR accuracy is by correcting the trajectory. Some SLAM LiDAR scanners let you manually adjust loop closure in their software, but that option isn't available on the SHARE scanner. Now I'm collecting the first ground control point. I have numbered the board so each one matches the point number in the scan. I usually collect the boards counterclockwise. That way, it's easy to identify which board corresponds to which point in the scan data. I tested the C1's indoor accuracy when collecting GCPs, and it was only about 5 to 6 millimeters. That's why it's important to place the crosshair precisely on the checkerboard center. It's important to keep tracks of which board corresponds to each GCP. Make sure you have a system to remember the board to point pairing. In SharePoint Cloud Studio, I will start by creating a new project. Then I go into data calculation and process the fixed scan first, the one captured with RTK. Next, I will enable GNSS Fusion. I will select the source coordinate system, then the target, which in this case is the same one. For my region, I will set a height offset of 29 meters. That's because WGS84 uses ellipsoidal height, not the mean sea level. By applying the 29 meter offset, I bring the data to MSL. I will turn off the undistorted photo output since I'm not doing 3D Gaussian splatting, and then I will start the calculations. Now that the fixed scan is ready, I will extract the coordinates. First, I will zoom into the checkerboard marker, open the measurement tab, and click directly on the center of the board. Click Save, then copy the coordinates and paste it into a notepad. I will repeat the same process for the rest of the boards. If you are not using RTK, the coordinates will be output as a simple XYZ values. In the same project, I go back to the data calculation, add the second scan, and process it. This scan will be aligned to the first one we already fixed with RTK. Enable the control point function, click the edit icon, and then copy the coordinates from the notepad into the GCP table. Then I click Save and start the calculation. Now the second scan has been successfully aligned to the first one. When I turn both scans on, there is no color shifting on the walls. Let me show you by toggling the visibility of one scan on and off. There is no color shifting at all. I can't achieve this level of accuracy with the manual alignment in Cloud Compare. Now the SLAM mode scan is georeferenced. You can also merge multiple aligned scan datasets into one by using the merging functions. This function is only for merging. To align scans, you need to use the GCP function. When I import the aligned SLAM data into BricsCAD and enable the geolocation function, the location matches the street map and the orientation aligns to the true north. This is a critical feature when creating a master plan since the plan must be oriented to the true north. The checkerboard STL file isn't painted, so you will need a multicolor printer to produce it. I recommend using PTG or ABS filament. For extra stability, you can add anti-slip rubber to the underside. Right? Thanks you guys for watching. I'll see you in the next video.